Well, hello, Lorraine. You're most welcome to Cornucopia Climate Chats. Lorraine is full professor of astronomy at UCD. And today we're going to be talking about climate, of course, because this is the Cornucopia Climate Chats, but how space can help in the whole arena of climate change, climate mitigation. And I suppose specifically about satellites. But first of all, Lorraine, you're most welcome.
Hi,
And
Deirdre. Thank you.
yes, I would like to ask you a little bit about yourself, how you came into the space, and just a little bit about yourself and what inspired you to become an astronomer.
Thanks, Deirdre. I'm delighted to be on the Cornucopia podcast with you. And to start, I suppose I got my chance to be involved in the space sector a long time ago now, back in the late 1980s, when one of my physics professors in UCD asked me to help him out on a project that he was working on, a new space mission. And I didn't realize at the time that we're members of the European Space Agency. So Irish students and companies and researchers can work on these massive European Space Agency projects, which are really at the cutting edge. And that was my first taste of space research, and I loved it. And I managed to work in the European Space Agency before I came back to UCD.
Wonderful. And as a child, Lorraine, what inspired you? That even
I
as a young person.
Yeah, I think I was always interested in things that can fly. I was always interested in aviation. I used to spend a lot of my summers cycling out to the back of the airport and watching aircraft. And now I'm a twitcher, a part-time twitcher. I love bird watching, so I'm always fascinated by the sky and by space.
Okay, so it was a natural thing. And now, so now that we're in 2025, we're concerned about climate. And I know that as part of your work with the European Space Agency, you have recently launched an Irish satellite, AirSight 1. So that's fantastic. So you're in the satellite space.
We were really thrilled that we were able to launch Ireland's first satellite back in December 23, and it's operating brilliantly. The team at UCD of students and researchers did an amazing job with ESA support, of course, and it's detecting these cosmic explosions that I've studied for a very long time now called gamma ray bursts. And we're excited by them because they tell us about these very violent explosions that happen mainly when very massive stars way beyond our own galaxy die, and they produce these flashes of gamma rays, which we can pick up with our instrument.
And you can tell from these gamma rays, because you were telling me this one day when I was asking you, you can read the gamma rays to tell you how far away and how long ago. Am I correct in thinking that?
Yeah, we can use these explosions to pinpoint the gamma rays to pinpoint where the explosion happened on the sky, and then we can use that information to follow up with telescopes, other telescopes that can figure out how far away they are. So it's a very complicated chain, but picking up the gamma rays is the first step.
I know they're far, far away. So not so far away are our satellites. How far up, if you were to fly up, are satellites that tell us about climate, or even that tell us about communications and all the other uses of satellites? How far up are they? How many kilometers?
Usually around 500 kilometers is where we would find 600 kilometers, where we find a lot of the satellites that we use to look at the Earth. You can be a bit lower, like the International Space Station is more like 430 kilometers, but it's really not that far. The problem is you have to go up and you have to do that against Earth's gravity. So you need a lot of rocket fuel, a powerful rocket to get up to space. And then, depending on the mission that your satellite has to accomplish, it could be in a very different orbit. For example, these communication satellites you mentioned that we use for satellite TV and for communications, mobile phone connections, they could be as high as 36,000 kilometers above the surface of the Earth. And that means they more or less keep a fixed position relative to the Earth. So they're tracking the same location, which is useful for that use. So there are many different places that you can send your satellites. Some, we're looking at the sun, maybe in orbit around the sun or around other planetary bodies in the solar system, for example, or on Mars or Venus. So for our purposes today, most of the satellites are at around 600 kilometers and orbit the Earth every hour and a half or so.
And what is a satellite? I can just say at a most basic level, because I didn't know a lot about satellites until I started to study prior to talking to you today. What exactly is a satellite? What's their origin?
Their origin is from the Cold War era, rocketry developed during the Second World War in particular. And when that capability for launching things into space, it became apparent that there was a lot of military aspects potentially to having eyes in the sky. So a lot of the early satellites would have been to look, they were spy satellites effectively. The building blocks for a satellite are the sensor, which is the camera or the radar or the scientific instrument. And then that's backed up by, a computer, by power supplies like batteries. And then you would have solar panels like we do on many of our houses that generates electricity from the sun to power the satellite. And then communication systems, so it can relay the data to Earth. And you'd also have things to point the satellite. So if you want to look at different parts of the Earth, for example, if it's an Earth observation satellite. So these are the kind of building blocks of a satellite: sensor plus all the kind of boring stuff to get computer power and communications to Earth.
And in terms of climate, obviously, in my understanding, Lorraine, that it's about collecting data, and then that data needs to be used in some kind of way back down here in Earth. So that's a very important point. But one of the things that we talked about, because we've chatted about this a good lot, is the fact that one of the first things that satellites do, or any space, if humans can look down at the planet Earth from the distance of 500 kilometers, it gives a sense of planetary consciousness, I suppose you could call it. I think you had a different word for it, an overview of planet Earth, because one of the things that we need to do with climate is inspire people. One, not to be scared, and two, to take action, to have a call to action. And sometimes I feel that the view from space of our planet is something that might allow people to feel more motivated. I wonder if you can tell me about that, or what your feelings are about that, the blue jewel.
I think you're right that inspiration is really important in the climate story because people can feel stuck, they can feel powerless. And sometimes getting that wide view, what astronauts call the overview effect of leaving Earth and looking at it from space and seeing how precious that blue marble is just hanging in the vast darkness of space is, reinforces the idea, hey, this is our home planet and there's only one of them that we know of, and very likely only one. Science now has uncovered more than 5,800 planets around other stars, and many of them planetary systems, so multiple planets orbiting other stars. So you think, well, there's thousands of planets outside our solar system. We have 8 planets in our solar system. We know of thousands of others already. Surely there's going to be another one, or 10, or 1,000 like Earth. But so far we've found nothing that resembles Earth. Doesn't mean there isn't one out there. But even if there is, it's unreachable to us, and it's not viable for us to pin our hopes for humanity's future on moving to another planet in the next 50, 70, 100 years, in my view. All of these planets have different limitations. Some of them are very near their sun, so they're far too hot. So even if they're rocky, the rock is molten. So you couldn't live there. A lot of them are gas giants like Jupiter. How could you live there? So I think it's magical thinking to consider that going to another planet, even another planet in our solar system, is the way to resolve the issues we face on planet Earth. And I do think that space, just from a humanity point of view, there's a driver in us, isn't there, to explore, and we do need to explore, and we want to explore, and we should continue to explore. but it doesn't mean that we've no responsibility and no need and urgency to really clean up our act on Earth and make sure we leave a livable planet for our future.
Well, very well said, Lorraine. It's true. I do believe that humans, you can't stop this drive to explore, this drive for the new frontier. I'm very aware of that. So that needs to be balanced, and I respect it, and I have it in myself. I've always been excited by the idea of other planets, but they're so far away as to make no difference. Meanwhile, we need to sort things out here. So, how do you think that satellites help in the climate space? Can you give me some examples? There's myriad ways, of course, but what are some of the ones that occur to you as being important?
We have really comprehensive coverage of the planet through several European programs in particular. And I think that's been really important because they give us a continuous monitoring capability of a very long time base. Because often what's hard to capture is, you may have a satellite that can do a job now, but it doesn't tell us about 20 years ago. So we can't see how much things have changed and feed that information into the models of how things may change under future conditions. So I think that's been really important for Europe to keep that capability, and the US as well has done that. I mean, some examples are then on the kind of science space that I would like to talk about. One being Cryosat, which was an Earth Explorer mission from the European Space Agency that launched in 2010. And it was measuring the thickness of the polar sea ice. And you might say, well, didn't we know how much polar sea ice? No, we didn't know that. And by having that mission there now for a long time, it's been able to monitor the change and the drastic reduction in the polar sea ice. So that's one example, because that rate of change can be captured. We've got robust and reliable data, and we can feed that into models to understand the impact of dumping all that sea ice into liquid form, what the impact of that on the Earth's oceans, for example, is, on salinity, on sea level rise, etc. And then a new mission that's coming up, which is really exciting, is called Biomass. And that's another ESA mission that should be launching very soon. And that's going to deliver crucial information about the state of our forests on Earth and how they're changing. And again, really trying to understand the role that forests play in the carbon cycle.
Very interesting. Very interesting. That's very good. I wanted to ask you about the oceans. You mentioned the oceans, and it's often occurred to me, and I'm not the first one to say it, of course, that our planet should be called ocean and not Earth, because we have so much more ocean space than we have Earth space. And historically, it's often been an area that's sort of uncharted and unmonitored, and there's a lot happening on our oceans that is still unmonitored, and a lot of illegal things. There's always been pirating, of course, but can you speak anything about that? Because that was so interesting.
You're right. We are a water world in many ways. I read recently that something like 90% of global trade happens across the oceans through shipments and so on. And we have ways of monitoring shipping traffic. Ships are supposed to carry an AIS transponder, which is essentially a signal where it tells you information about its journey, and what it's transporting. But often these don't work very well away from the shore, so going across the deep oceans. And that's where satellite AIS transponders come in, because they can track ships no matter where they are on the globe. And what we can also use satellite data for is to actually look at the shipping traffic. So physically take images either with radar or optical, and be able to measure the size of the ship and ensure that that ties in with what it's telling us through its transponder, and verify that it is who it says it is. So I think satellites, again, are going to play an increasing role and service to many agencies and actors who need that information to hopefully make shipping a much safer and less dangerous activity for humans and for trade.
Very good. And thanks, Lorraine. Thanks. Oh, very interesting. And closer to home, we were talking once about Loch Ness and one of the biggest lakes on our island. And it has become quite ill, I think, due to
Yes.
agriculture. Can you tell us how a satellite might help in that effort?
That's a really good question because it's Lough Neagh, as you will have seen in the news, has been suffering from what are called algal blooms over the past couple of years. And that's these algae which are very happy when nutrient rich, for example, fertilizer gets dumped into a water body and warm temperatures. So warming temperatures also promote the growth of these algal blooms. And they're not good, and particularly when you're relying on water bodies for drinking water and other services. Recently in Northern Ireland, a study has started now with three different companies and universities using satellite data to provide essentially an early warning system to predict when these algal blooms are starting to develop so that authorities could take action much earlier to remedy the situation before the algal bloom gets out of control. And then similarly to what I mentioned earlier, the satellites will also give us this long-term historical data to work from and say, it's typically under certain conditions of weather, certain times of year, where these things are more likely to happen. So we can take remedial action ahead of time and prevent them from actually forming if we understand that behavior. So it's a lot of data from satellites. It's also going to use in situ data, of course, and new techniques with AI and machine learning to crunch all these data sets and make sense of them and provide authorities with useful information.
Of course, there's the taking of the data and turning it into action, positive action. There can be almost too much information. One of the things, too, that was really important in terms of communication for areas where there isn't internet, satellites can provide that out of the way areas that you couldn't possibly get the infrastructure there. Can you tell us about that, Lorraine?
So that's a big area. And it's quite different now to what I was saying earlier about these geostationary orbits that are at 36,000 kilometers. In these new satellite constellations for communications, the satellites are at a lower altitude, so that more like our Earth observation satellites. But now there are dozens and dozens and dozens of satellites in that network. And so they basically share data amongst themselves. They carry signals from one part of the globe to the other, but now it's via these satellite relays instead of through, as you said, optical fibers or cables. And I know people in Ireland who have satellite delivered broadband in their homes now because they can't get fiber or cable to their house. So it is becoming a big, huge area, and we've seen how it's been used in, areas under conflict, for example, that people can have access to the internet in the outside world in conflict regions. So it's an incredibly important piece of infrastructure that is developing low-cost satellite-enabled broadband and internet. And that's going to become more and more of I think, a space, no pun intended, for companies to build on. So there's a US-based company with an Irish director called Rivada Networks who are trying to build another constellation for such services, mainly to industry, mainly to businesses. Companies like OneWeb and Eutelsat, they also provide these business-to-business broadband services. So it is a hugely growing sector and will become an important piece of critical infrastructure in the future.
Well, I have to say, I'm very grateful to satellites because I could never find my way anywhere until I have my GPS. I don't know how I survived without it. And we're all quite dependent on satellites now, aren't we? So, with so many of them up there, there came the question to me about litter. Are we littering up there in the same way we've littered down here? And cleaning up space litter, is that an issue? And it's quite dangerous, isn't it? Because it's all going at such a high velocity, little bits of things. So tell us about litter in space and what we can do about it.
Yes, space debris is a growing concern for sure, because if a lot of satellites are orbiting at similar altitudes, there's a risk of collision. So a lot of satellites now will have on board what we call propulsion, and that means they can give themselves a little boost. So if there's an early warning that there's a piece of space debris headed their way, then the satellite can move to avoid it. So collision avoidance, traffic management basically in space is becoming a growing service that's essential, I think, because some of these satellites do provide critical infrastructure. Now we have quite strong regulation, and if you're a responsible space actor, you are under an obligation to deorbit your satellite within a particular number of years, or put it to what's called a graveyard orbit. So put it far away from Earth so it can't re-enter. And I think that's, as I say, important for good, responsible space users, but not everyone is such a user. And there have been incidences where a country has basically fired a missile at one of its own satellites, creating many thousands of pieces of debris in the process as an experiment. But now we have another 7,000 pieces of debris that have to be tracked and monitored, and their paths monitored, so that if they do run the risk of colliding, that satellites are given an early warning, and can get out of the way. But that was totally avoidable, right? That didn't have to be the case. We're not that far away from a situation where a couple of more of those episodes essentially create a runaway effect, and that then it spirals exponentially, and low Earth orbit would become unusable. So there's a big effort now to clean up space. A lot of missions, a lot of concepts are being tested to try and remove this debris. So if we can't rely on good user behavior, then we may have technological solutions as well to get rid of some of the worst offenders up there.
Great. That's really good that there's a cleanup operation. But imagine humans, no matter where we go, we don't seem to bother with the cleanup. Move on to the next thing, leave a mess. So I think that the photos taken from space are very important. Can you tell me if there's much research on actually going to Mars? You know, the way it's been so center stage with different things happening in the political arena at the moment. You were saying to me that in UCD, they're actually planning to use, humans are planning to use building materials that are on the moon, to use the moon as a launch pad to get to Mars, and how soon that would happen and all of that. Given that we sort things out on this planet and keep it clean and happy and with it and get rid of our problems in terms of climate, obviously we will be going to our neighborhood moon and Mars also. That's, I think, inevitable. Can you speak about that, Lorraine?
We're definitely heading back to the moon, and the plan is with the Artemis program that there will be astronauts back on the moon probably in 2027, 28, all going well. And when you think about it, astronauts are a great example of sustainable living, because everything they have to bring with them, and they have to recycle and reuse every single gram of material they bring with them to survive. So when they get to the moon, they can bring some material, but they need to be able to reuse materials that they create, whether it's air, whether it's clean water. And also they need to be able to manufacture habitats for themselves when they're up there. And that's certainly a colleague's research in UCD, David McKeown, is looking at robotic arms on the lunar surface and trying to keep robots clean, because the lunar regolith is very tricky to work with. It's very, very sharp. It hasn't been weathered like stones and rocks here have been weathered, because there's no atmosphere on the moon. So it's very sharp, and it covers and clings to everything. So he's working on robotic systems and cleanliness for lunar research and manufacturing. But then, as you say, the plan is that this would be also the jumping off point, if you like, to get to Mars, so that on the moon, the astronauts would make fuel for rockets that would allow them to travel to Mars, because the smaller moon's gravity is easier to escape than Earth's gravity. So there's a big win if you can do all that from the moon. So I think once we get to Mars, then the challenge is trying to grow plants that we can use. So there's a horrible material on the Martian soil that would be toxic. So I have another colleague in UCD, Nick Brereton, who is looking at symbiotic plants that could grow together, one of which could clean up the soil as it grows so that the other plant could actually be harvested and eaten. So that's a very active area of research as well. We have many challenges, of course, but as we spoke about earlier, it is about that drive to explore and keep moving outwards.
Yes, Lorraine, the drive to explore and what could be created. And I think keeping inspired is so important for humanity's development. Being inspired, we do so much when we're inspired or when our back is against the wall. So I think our back is against the wall in terms of climate. So let's hope all the research, the engineering, the science, the legislation, everything comes together to create what it is that we need. But certainly satellites and the eye in the sky will help us see the planet from a different perspective. So just on a lighter note, are there any books that you'd recommend for our Cornucopia climate listeners, our Cornucopia people, that would be inspirational or fun or anything?
So I loved a book, actually, it's a trilogy called The Calculating Stars by Mary Robinette Cowell. And I love this because I don't know if you're aware, but back in the early days of the American astronaut training program, there was a group of women who were also tested for spaceflight. They were all had been pilots during the Second World War, doing crop spraying and so on. And they actually looked like they would be on track to become astronauts in the early 60s until the program was killed. It was never an official program. But this book, The Calculating Stars, imagines an alternate history of spaceflight if women astronauts had been part of the space program from the early days. And it's a fascinating trilogy, and I strongly recommend it. And if you're interested in the kind of factual basis, there's a great Netflix documentary called Mercury 13 about the women who underwent this astronaut training program in the early 60s.
Great. And Lorraine, have you ever wanted to be an astronaut, or is it something you'd recommend to your granddaughters or your grandsons?
I've never wanted to be an astronaut. I think I'm too much of a wuss to go through all that horror. The idea of being, dunked underwater in a capsule and having to escape terrifies me. So no, I don't have the right stuff in that regard.
Very good. And any other movies that you'd recommend, films to inspire people?
Definitely. Well, The Martian, obviously. Growing potatoes on Mars. What a great story. And another wonderful TV series is For All Mankind, which is again a slightly alternate drama of the space program that starts from the premise that the Russians were the first to reach the moon. So it kind of parallel tracks a lot of factual stuff, but obviously it's a dramatization and it's wonderful. And then, of course, The Expanse is probably my favorite series of books and TV series. Well worth it.
The Expanse. What's
The
that?
Expanse. It's one of these big space opera, galaxy spanning, civilization creating, world building stories that's just totally mesmerizing. And then I have to give a shout out to my old friend Alistair Reynolds, who writes wonderful space opera and has been a very successful writer who was also an astrophysicist with me back in our early career.
Okay, well, it's all very inspirational on the theme of inspiring. So thank you so much, Lorraine. Is there anything else that you'd like to add about being an astronomy professor? Are your students inspired? What have you found inspirational about teaching people? Just I'm interested. It's such a wonderful career to have had or to have.
For sure, the working with students is probably my favorite part of the job because every year you meet a whole new cohort of students that surprise you in umpteen ways and impress you and yeah, do inspire and give you hope because they're so excited and so motivated for the future and don't see barriers. They just see possibilities. And it's just a wonderful privilege to be able to help them on their journey.
Thanks, Lorraine. Thank you so much. And see you again soon. And do enjoy your work. Thank you, Lorraine. Bye
Thank you
bye.
so much. Bye, Deirdre.